Okay, we're going to look at this worksheet called Lesson 5.4 Tension in Multiple Blocks, and we're going to look at the multiple block problems. We'll do this one correctly second, but that one's a little bit more difficult because it's on an angle. So let's do a easier one first, and then we'll get back to that one. So let's flip to the back, and let's just do this one. Number 6. So for number 6, it says the horizontal surface on which the object slides is frictionless. If m is equal to 1 kilogram, the magnitude of the force of the small block on the large block is 5.2. Determine F. So because of Newton's third law, when you have the two blocks, I have this block and this one, they're going to have a contact force in between them. So this block is going to exert this 2m block is going to exert a force here, and then this block is going to exert an equal and opposite force on the other block. So what you do first you do it as a system. And why are we doing it as a system? Because we want to find the acceleration. These two are moving together because there's this applied force here. So we want to find the acceleration of the system. So first I apply Newton's second law and say F net is equal to ma. So the net force, F, is equal to the mass, which would be the combined mass, 2m plus 4m, times the acceleration. So when I rearrange this, I get F is equal to 6ma. So don't they tell me, the mass is 1, so this is 1. So F is equal to 6 times 1 times A, so F is equal to 6A. Now, you can do either block. Now, how do I know which block I want to use? Because it says determine F. Well, F is next to this block, and they tell you that the contact force is 5.2 newtons. So I'm going to draw my free body diagram for one of the blocks. So I'm going to do it for the 2m block. And why am I doing the 2m block? Because the force is there. Now remember, forces act out of the center of mass. So I'm going to make this force going this way. Even though it looks this way, it has to come out of the center of mass. And then the contact force between the two, I'm going to make it go this way. I mean, I could call it F24 or F12 between block 1 and 2, or you can call it whatever you want. I'll call it FC for contact. Because remember, these contact forces are going to be equal and opposite. So for the 2m block, if I wanted to apply Newton's law to this and say F net is equal to ma, so this is going to be, well, m is 2, so it's going to be 2 times 1, that's the mass, 2m, times a. So F net is equal to 2a. Now, when I apply, so that's just my net force, F is equal to ma. But if I just do it the way we did it before. So F net is equal to ma. And now what are the net forces acting on this block? Because basically what I did was I found that. So I have the force, which is positive, minus the contact force, because it's going in the opposite direction. And that's equal to ma. So basically I have F, which is 6a, minus the contact force, which they told me is 5.2 newtons, and that's equal to ma, which I already found out here is 2a. So now my only unknown here is a. So I just rearrange the equation and subtract 2a from both sides. So I have 4a is equal to 5.2 newtons. So a is equal to 5.2 over 4. So A is 1.3 meters per second squared. So that's the acceleration. And they asked me to do, oh, they said, what is F? So F is equal to ma. So I can just do, it doesn't matter, I can do so F is equal to 6 times 1.3 is equal to 7.8 newtons. I just did it for the system. Okay? And that's it. So that's that one. Now, number 3 on the front, I did it incorrectly. I don't know why, but I did, because it's on an angle, and I don't know why I was looking at it and not seeing the angles. So number 3 on the front, okay, I have the 3 kilogram mass, and then I have the 2 kilogram mass. Now the force is going up like this. And what they tell us is, they tell us that the force is equal to 30 newtons. And it says, what is the magnitude of the force exerted on the 3 kilogram block by the 2 kilogram block? So they want to find the contact force. I mean, you can call it contact, F23, whatever. Well, what I did before was I wasn't even thinking about the component of the weight that acts parallel to the surface. And you have to take that into consideration. So when you look at the free body diagram for these two, this is the weight going down of the 3 kilogram block. And when I have the weight, I'm going to break my weight up into its horizontal and vertical components. So this is the perpendicular component, which is I can call F3y, and this is going to be F3x. So you see that this component is going down, and then I'm going to have the same thing for the 2 kilogram block, where the weight's going to act down, and then I'm going to have the components. So there is going to be a component of both of these blocks acting parallel to the surfaces in contact, and I have to take that into consideration. So I don't know what I did before, and I don't know how it came out to be whatever the right answer is. So how do we do this? Well, first of all, I want to look at what is the net force acting on the system. And the net force, F net, and let's just forget about the MA, what is the net force acting on the system? So if I redraw my free body diagram, and I'm just going to draw it like this so it's easier, my force goes this way because it's pushing up. Now these two components are acting in the opposite direction. Remember, you always want your sign convention to go in the direction in which the object is moving. So in this case, it's moving to the left. So now these two components are going in the opposite direction. So I have here, I'll just call this F3x. It's the component of the weight. And then I have F2x. So now when I find my net forces acting in the x direction, just that left part of the equation, the net forces are going to be 30 newtons, which is positive, minus F3x minus F2x. Now to calculate this, remember they gave us this angle was 30 degrees. And so these are 30 degrees. So when I do this, F3x ends up being, what is this one, 3. So it's 3 times, I can use 10 times the sine of 30, because this is opposite. So this one comes out to be 15 newtons. And then F2x comes out to be 10 newtons. So now when we sum forces, my net force is equal to 30 newtons minus 15 minus 10. So my net force is equal to 5 newtons. Now if I do F net is equal to MA, because remember that's equal to MA, I know the combined mass of the system is 2 plus 3 is 5. So this is 5 times A. So A comes out to be 1 meter per second squared. That's my acceleration. Now, if I want to find this contact force, which block do I use? Do I use the 3 kilogram block or do I use the 2 kilogram block? It doesn't matter. You're going to get the same answer if you do it either way. So let's say I took the 3 kilogram block. Here's my 3 kilogram block, and I have the contact force, which is going this way, so I'm going to draw it this way. And then I have the component of the X force going in the opposite direction. So this ends up being F3 parallel. So F net is equal to F contact minus F3 parallel. Now, what is this net force? Well, this is MA, so this is 3 times my acceleration, and that's equal to my contact force minus F3 parallel, which is 15. So 3 newtons is equal to my contact force minus 15. So just put it on the other side, and the contact force ends up being 15. Now, what if I did the free body diagram for the other block? Well, if I did it for the other block, now remember the contact force goes the other way, and the component goes this way. I should call it X instead of parallel. And when I sum forces this way on the 2 kilogram block, I say F net is equal to MA. Now this net force is going to be where's my F? Oh, the F is going the other way. So in the 2 kilogram block, F net is going to be MA. So MA is going to be 2 kilograms times 1, which ends up being 2 newtons. And then when I do my net force is equal to the, I forgot my applied force here. Where did I do my applied force in the other picture? Oh, it's not on there because it's on this block. So this is equal to 30 newtons, which is positive, minus the contact force minus the component of the weight, which we already figured out is 10. So F net is equal to 30 minus the contact force minus 10. So this adds up to 20, and I know my net force is 2 minus Fc, so the contact force is equal to 18. Oh, I wrote that wrong. 15 plus 3 is 18. Whoops. So either way, you get the same answer, or you should get the same answer, which should be 18 newtons. So again, first you do the system, and it doesn't matter which block I do, I should still get the same answer.